In this video, we're going to be converting Ralph's 71 GMC pickup. It's got a LS3 4L60 combo with a factory style computer on it. We're going to convert it to FiTech's intake manifold, cable throttle body, dual wideband sensors, and our ECU to control the engine and transmission together. That's going to give the drivability and the tunability with a handheld without requiring custom programming. Another benefit of having the FiTech computer is the dual widebands gets rid of the mass airflow sensor. We have speed density, so we can run a new cam, a big boost, whatever we wanted. We don't have to worry about it with the factory computer limiting you on many of those areas. Let's get started on this. We're going to be pulling the hood, pulling the system out, pulling the harness out, and then adding our stuff and tuning it and sending it back with the customer.
I'd like to cover the injector holes before I put the manifold on, just to keep debris, maybe washer fall down, can fall right through there into the intake port. So if you try to put the fuel rails on ahead of time, they kind of get in the way of the bolts to hold the intake manifold on. So I usually put the intake manifold down and then put the fuel rails on. Some guys do it the other way. You can, but this is just a personal preference. Okay, let's go. Okay, this engine's very new, less than probably 100 miles, so it's very, very clean, and it just has a little bit of residue from the fuel, so I'm going to clean it off. If you've got an older engine, you're probably going to have to get out the vacuum cleaner and clean all the debris and make sure there's no debris that's going to get down inside the intake ports. But luckily on this engine, it's really, really clean. Nice to have one of these long 5mm extensions with the ball on the end, so you can get a little bit of an angle. I find these very handy. It's real hard to do with a little small set of Allens. You want to use a cross pattern to tighten these down, and you don't want to over tighten any of them, and you want to go back and forth probably 3 times. And usually I do it by hand, the last ones. And once the engine's warmed up and cooled down, it's a good idea to tighten them again one last time. There again, the long extension with the ball really helps out, because the fuel rails will usually be on it by then. And you always want to put the label so the FiTech shows out. FiTech label always goes outboard so you can read it. The way the injectors would normally go would be outboard, but because the ignition coil bracket is so close, I'm going to put the injectors inboard, which will give it enough clearance for the wiring. Otherwise it's just a little too tight. So I'll pop it back off and pull the injectors out and turn them the other way. That way the injectors are, the name is still out, but the injector plugs are in. One of the other reasons for having the FiTech label showing is because these holes are countersunk. So it's not just because we want to show it, of course, but it's because the holes are countersunk and the bolts that are going to go in there will sit flush. If you turn it back the other way, the bolts are going to stick out. So this is the way you want to go in. And now we've got room for the plugs on the inboard side. These bolts hold the fuel rail to the brackets, so they go in like this. And they have a the lock nut that holds them on. So we want to just start them all by hand. Okay, I'm just going to snug these up but not tighten them fully, because I want to tighten down the 3 bolts to the intake that hold the brackets. Luckily we can use the fuel line that was already on the engine. It's a -6 female. Our fuel rail has a -6 male, so it's going to work. So we got that, and we're going to put the crossover on in the front so we can feed fuel to the other side. And then I have a cap for the other end, the fuel rail. Cap it off. Okay, you want to tighten these on the fuel rail. Just snug them up. There's a big O-ring in there, but you still need to snug it. So you want to use a backup wrench on the fuel rail, and then pull the wrenches together to tighten it. Don't try to tighten it like this. It's way easier to tighten it so they're trying to go together, like so. Okay, I'll take these off, get these out of the way, and start putting the other ones on. The new coil. All right, now that we've got all the intake manifold, fuel injectors, and the fuel system hooked up, we're going to move on to the wiring. And our system has a accessory leads out for the fan, AC control, tach, speedo, brake, and a couple other ones. Now, this is all in one sheath, so what you want to do, you want to take and cut the tape off and pull the ones out that go inside, and separate them from the ones that go outside. There's no sense running all this outside and then running wires back inside. That doesn't make sense. And you want to keep the labels on for sure, or take a picture of it before you start it, because it's very important to get it hooked up right. Okay, I'm going to cut the tape without cutting my finger or the wires. The tape is really on there tight. All right, now that we've got the wires separated, we're gonna break out which ones go inside. Okay, yellow wire goes to the brake. Black goes to the speedo. Of course, your tack goes inside also, which is the white wire. So we're going to pull those back out of the harness. Now that leaves the AC request, which turns the fans on when the AC compressor kicks in, and that's the brown wire. And then you have fan 1 is green, turns the fan on, and fan 2 is blue. Now these are ground signals. These do not run the fan. They will burn up. We've had people try it, but they will not handle the electric load. They have to go through a relay. So we're going to put these back in the harness. Because those are going to go outside. Now they're going to go, there's no sense taping this all up yet because these go to 2 different places. So I'm going to pull these back for the inside. Alright, and that should do, this is all going to mount by the glove box. So this will give me enough lead to go to the gauges. And then this is going to go outside. So the next thing we're going to do is we're going to push all this through the hole in the floorboard. We have the main power wire and the crank position sensor. Those go on the passenger side, down behind the engine, towards the starter. This is a gray sensor, indicates 58X, as opposed to the black sensor, which usually indicates 24X. Right here we got a VSS wire, which is vehicle speed sensor, and of course that has to go to the back of the transmission. This is a 4L60. Now on a 4L80, here's the tip. There is two places to plug the sensor in. You want to plug it into the one in the very rear. Otherwise the speed will not be right. We have a map sensor plug, which is in the back of the manifold. I have a ground wire we're going to hook up later. Fish those through to the front.
You also have to be careful with the coil sub harnesses. These will fit upside down, and if it's upside down, it won't run properly. To make sure that it's on correctly, there should be a purple wire in cylinder 1 and a purple wire in cylinder 8.
That's correct.
If you don't, it may run on one bank or run on several cylinders, but it will actually pop and bang and likely damage the engine if you run it for very long that way.
Most LSs come with a NGK style TR5 heat range plug, which could be a different brand, maybe HC Delco or something like that. But for most applications, you might want to run one step colder, which would be NGK TR6. We've always had good luck with that spark plug. And always make sure you put anti-seize on the threads if you're putting spark plugs in. Otherwise you could damage the cylinder head. they are a resistor plug, which you definitely do need. I don't even know if they make that style plug without resistor, but make sure they're a resistor plug. All of our systems, to eliminate noise, which could mess up the computer signal, need to have resistor spark plugs. It's just nowadays, you just don't want that RF noise into anything. It could cause a malfunction, misfire. Now we got to go with the injector harnesses. It's just too close to the coil the other way.
It's too close to the intake this way. Well, it looks like we're going to have to flip the injectors to the outside. We thought it would fit on this manifold with this connector, but it doesn't. So all we have to do is loosen the fuel rail mounts, slide the injector down and flip it around. We may need to be a little careful when we put it on. Maybe it needs to angle a little bit, but on the LS1 manifolds it does fit that way. On the LS3 it's not.
Alright, so now I've turned the injectors around. We're gonna hook up the injector little sub harness, and you'll hear a click when they go on properly. Okay, so now we got to find the female part of the harness where the injectors plug into. And it is marked injector D, which is driver side. Do not mix them up. Okay, snaps in real easy. So the wiring's looking good on this side. Now, on this build we have a performance LS3, so we're going to use two O2s, two wideband O2s. So we have a oxygen sensor extension harness for the passenger side. So do not get them mixed up, it won't run right. It's got to go to the passenger side. So this will be the plug that goes to the O2. This is going to be the plug that goes to the wiring harness. We have a plug for the transmission and a plug for the NOx sensor. Let's say NOx sensor extension harness. So this will be the NOx sensor extension harness for LS3 NOx sensors. And if you have an early LS, this usually will plug right in because the NOx sensors are underneath the intake. It's a good idea to use it. It can be turned off if you have a engine with noisy valve train. But it's a good idea to use it. Okay, we'll raise it up and see what we got. Okay, I had to pull the wires. They were stuck around the dipstick tubes. I had to get them back where I could work on them. This is a transmission harness. It plugs into the main harness. You'll see two of them marked trans, and they're completely different, so there's no way to get them backwards. It's got to line up the little slots inside, and it snaps together like it should. And we got that one plugged in. Okay, so the transmission plug on the 4L60 is towards the rear on the passenger side. The 4L80 will be on the driver's side rear. We got the main plug that goes on to the transmission. We want to feed it so it's away from the heat exhaust, and we're going to plug it in. Try to coil it up because it's quite a bit long. There is an arrow marked on the plug. It goes outboard. And there, clicked in. So all this is going to have to be zip tied up away from the heat, of course. Okay, there's one other thing we need to look for while we're here is the VSS plug. It's a little 2-pin plug that goes onto the back of the transmission. We'll have to find that and plug it in. Okay, so while we're here, right above on the passenger side is the extension for the second O2. So it's a 6-pin plug, completely different than the transmission. So there again, you can't get it mixed up. Just got to line up the little slots, and that's snapped together good. All right, so now what we're going to do is we're going to put the O2s in and then hook up the O2 wiring, which is just plug in. This is the end from the harness. It has a heat covering on it. You should not lay it against the exhaust, even if it has a heat covering. It's just for radiant heat, which is heat that is removed from the source. Okay, so what I'm going to do is tuck it up high, and then we'll plug it in and we'll route it down here and zip tie it to something that's not going to get hot. And it snaps together. You should hear a click. I'm going to put the passenger side O2 in. Okay, we got the power wire and the crank position sensor. Now we can hook up the crank. It's a Grace crank position sensor, and it means 58X. If it's black, it usually means 24. But the easy way to tell is the cam sensor is in the back of the engine on a 24. Possible somebody could have moved it, but generally, if the cam sensor is in the front, it's 58X. This is the knock sensor plug. It goes. The knock sensors are already installed from the other kit, but it needs a ground right here. So I'm going to snap it in for the moment. Crank sensor simply plugs in, snaps. That extra lead, so you tuck it up behind the dipstick tube, but you want to get the heat covering so it's by the exhaust. Okay, and we have the main power wire is going to go to the starter, but I have to run the starter wire down before we can do any of that. So over here on this side we have another knock sensor. It's going to plug in. And this knock sensor needs a ground, so we're going to go ahead and take the bolt out that holds it and just use the bolt for the ground, which is perfectly acceptable. Okay, so knock sensor's done, the oxygen sensors are done. We got to go back up and do the ground. This ground gets pulled back up. This is actually the ground for the handheld. there's another ground for the main ECU that's up there, so we got to do that. And then I'll have to get the starter wire down, then we can finish the starter. And this wire here, I have to extend this wire, it's not long enough. I've got the VSS plugged in to the back of the transmission. This senses the drive shaft rotation. It tells the computer how fast it's going, of course, and it has a lot to do with determining the shift points. If this is not plugged in or the sensor is defective, the transmission will not shift correctly. These are the wires that go to the two wires that go to the fan, the blue and the green, and the one wire here, the brown, goes to the air conditioning. So the relays for the fan are down under the fender here. So what I'm going to do is pull the brown wire out, and we're going to put the rest of the wires down underneath so that I can hook them up to the relays. We're trying to keep this as clean as possible, and we want to try to hide the wires a little bit as best we can. So I'm going to route this underneath the intake manifold and bring it out the front here. Okay, we'll hook that up later, but the brown wire is going to be for the air conditioning request, not the AC trigger. Ground wire for the main harness comes out on the, generally comes out on the driver's side of the harness. The other ground wire is for the handheld, but I usually ground them all to the cylinder head. So that way everything is grounded together, everything works like it should. And the cylinder head is generally not painted, so you're going to get a good ground. Feed that down there and get the ground hooked up. Okay, we got that grounded. Okay, now we're going to put the starter back, but there's about 3 wires that have to go to the positive side. And then of course the trigger side also. So our system gets power from the starter off the battery post. Right now what we're going to do is hook up the fan trigger for the relay. The relays turn on the fans with temperature. There's 2 settings in our handheld, and also they come on with the air conditioning. So they are wired for our system provides a ground signal only for a relay, not enough to ground the fan itself. That has to be a whole separate ground through a big heavy wire. But the nice thing is you can set the temperature that you want it to come on right on the handheld. You don't have to have somebody program it for you. We're going to heat shrink this power wire right here. And then we'll crimp the other two and heat shrink those. And then I'll loom cover them later, but I want to make sure everything works properly before I loom cover everything. Always tug on the crimp. Make sure it's going to stay. Okay, that's going to plug into their relay system that they've already installed for the truck. So we'll test it to make sure everything works, and then we'll finish looming it up and tidy it up. We can hook up the cam sensor, and we talked about leaving the factory cam extension harness in place. So you want to do that so that the wires are in the correct orientation. So it's going to just plug right in, just like that. And it says right on it, LS3 cam. Okay, we got to do one more thing down here. We got to extend the knock sensor wire. I'm going to put a splice in here and then ground it to the knock sensor, and we're done underneath. Back here. Put a covering over that later, but I want to go ahead and hook it up. So I got to take one bolt out for the ground. That's the little ground wire. Basically what a knock sensor does, it listens, it's a little microphone in there. It picks up the vibration, certain frequencies that the computer uses to tell the engine that you got a problem, retard the timing. So it tries to retard the timing until the knock goes away. That's what the LS3 knock sensor looks like. And this is going to ground there, and then of course this plugs right into it. And you hear it click. And you got a ground. I'll put covering over this and then clamp it so it can't get into the heat. We've got this plate that was in the truck before, had the old ECU mounted to it, so I just re-drilled some of the holes to mount our ECU to it. So it's going to mount just like that, and I'm going to stand it off just a little bit probably. We're going to hook up the two wires from our ECU that go to the speedometer and the tachometer to the existing wires to the decoder digital dash display. So their wires are marked tach and speedo. So the black wire goes to the speedometer. And then the tachometer is white, and their color is white also. Now we've got to hook up the power wire for the key. Red wire right here. It's going to hook into their pink wire. I'm going to route the fuel pump wire over top the transmission away from the heat and connect into the wiring that was already there for the existing pump. So we have a relay and a fuse that's built into our system. So no worries on not having a fuse or, to protect the pump. It's all built in right in the fuse block.
For this test fire up, I'm gonna open up this screw. This actually opens the throttle blade. We will need to adjust this screw later when we're doing the quote setting on the IAC process. I'm just gonna open it up now because I don't have a throttle cable installed yet, but I do want to go through the initial setup and check for all the problems and make sure it's not leaking, make sure it's running smooth before we tidy it up a little more. Before I do the first startup, make sure to check every fuel fitting that you've been involved with here. Just make sure they're good and tight. Because fuel leaks are dangerous. When we key on them with the pressure, make sure all the injector O-rings are sealing properly. If you do happen to see a leak on an injector, before you go taking everything apart, try rolling it around a few times. Sometimes an O-ring, if it's not properly lubricated before going in, will twist itself, and that twisting will not provide a great seal until it untwists itself. Double check that all the fuel rail mounts are tight. If any of these come loose, it could cause a big problem with fuel spraying on the engine while it's running. You don't want that to happen. This truck has a filter regulator combo from a Corvette in the back. So we know it's already working well, but for making sure we have a good startup, we put the pressure gauge on there to verify that it is giving the correct pressure. You should do that too. It's easy to make a mistake when plumbing those Corvette regulators because the internet has pictures of them being plumbed the wrong way. We can show you a picture right now of how it should be plumbed. The inlet's going to be on the side that has also the return, so make sure those are plumbed correctly. The outlet's on the single fitting side that's going to go up to the engine. It's a deadhead system, so on the first startup, you may end up having some air in the lines that may have to get cranked out of the system. I don't recommend spraying fuel all over your engine by priming it by releasing one of the fittings, but that first few moments of operation of cranking may be injecting just air. So don't give up hope until you've got fuel pressure up at the rail. All right, so I'm gonna go through the initial setup on this. It's an LS3. Step 1, we have a 4L60E in here and a 58X. So I'm gonna go to this. So I'm riding the 58X 4L60E cal. We actually have the 55-pound injector, so I'm gonna have to change the injector flow rate in the calibration before we do a startup. Download succeed. I'm gonna go to initial setup. We have a 362 or probably cam. Let's try a cam 3, see how that goes. 750 idle. We're naturally aspirated. Injector flow. We are at the bigger injector, which is a 55. Just push OK. Sends to the ECU. So we have 2 fans. I'm going to turn the first fan on at 207. Second fan, or fan off at 205. Second fan, 212. 210. We do have AC, and we do want the fan to turn on with it. The auto transmission. We have a 4L60E, and I need to turn 4LXOE trans on to 4LXOE. That just enables the transmission control. Without it, you won't have any shifting at all. I don't know the size of the tires on this one, so I'm just gonna guess, but I'll go back out there and check in a little bit. Tach and speedo. This probably is set up as a standard tach and speedometer, so I'm gonna have to set up those properly later. We do have dual wide bands, and so this will do bank-to-bank air-fuel ratio control. So one bank and the other bank each have their own sensor, and the injectors on each side are adjusted accordingly to that sensor. So I've done all that setup. I'm gonna turn the key off. Turning the key off will let the calibration in the ECU save to its permanent memory. When these numbers disappear, that means everything has finally shut off. The next thing to do would be start it, so hopefully we have a good luck here. This thing has a air ride system, so I'm gonna give it a second. This is the very first crank. Hopefully we have a good luck starting. I'm gonna look for RPM. Actually, I'm going to first scroll down, make sure there's no faults. So there's no faults detected. That means everything's properly connected. That can be detected at stall. Crank. It's a little lean. It's adjusting. I'm going to go back and change it to cam 2. You can see it got richer really quickly, but that'll take that trim back out. But that first startup also, maybe there's air in the fuel lines, but I think we're pretty close with this cam 2 setting at idle. That 50 kPa, 1000 RPM. I maybe got lucky on the IAC. It's already closing completely. That means I've got that throttle screw adjusted too far to the opening direction. We have a little bit of steam coming off the engine right now. We'll probably go out there, make sure we're not burning anything, melting anything. But I don't have a gas pedal yet, so that initial setup, we got pretty close, just with a few numbers there. So I'm going to turn it off and go out, and we're going to check to see if everything's clear of all the exhaust system, make sure we're not melting anything, make sure no leaks. But yeah, we got pretty lucky there with a quick, easy startup. I'm going to start it again. I'm going to go through and force the fans to come on by turning the temperature settings on them very low to make sure that the wiring is correct. I don't want to get the engine hot and then wait for the fans to come on, just because by that time it may be too late. I want to do it with a cold test. It's very simple, you can do it on the fly. Program the fans to come on. Both are supposed to be on. Mike, can you tell if the fans are on? Yep, Both fans are working. Thanks, Mike. I am seeing a lot of trim reduction right now, so I'm going to go back and switch it to cam 3. This may stumble just a touch when I do it. Yeah, I may have just been combating the air in the lines at first, because it was a new setup. So cam 3, it's learning a little bit still. It's still showing kind of rich. Now it's pulling out quite a bit of fuel still. Faults. Oh, our battery voltage is low. That's our issue. So when the battery voltage is low, the injector turn-on time gets extended significantly. But if our voltage is not coming up like that, that may mean our alternator is not set up to work with our system.
In this particular truck, we found out that there's a 3 amp draw on the battery with everything off. It's got air ride, it's got stereo, it's got our equipment, and there might be some other thing that we don't even know about, but 3 amp draw will kill the battery within a day. I don't care how good a battery you have. So we're going to put a kill switch on the battery system. It's just a very simple switch. You can take the handle off, and it's actually a theft device also.
When you use a kill switch, make sure you don't turn it off very soon after you turn the key off. Turn the key off, make sure the ECU is fully powered down, turn the kill switch off. If you happen to turn the kill switch right at the wrong time, there's a chance of scrambling the calibration as it's saving its things from temporary memory to permanent memory. That's very important. And if you're going to be parking your vehicle for a few days, a week or more, even with a kill switch, it's a good idea to have a trickle charger or a maintenance charger on the battery, just so when you go up to fire it up the next time, it's ready to crank and start really well. After installing a throttle pedal and cable, make sure there's a little bit of slack at idle. Make sure when you push the pedal all the way down, you can get full throttle. Those two things are pretty important to make sure the throttle works correctly, lets you get to idle, and gives you the maximum power. On our 750 horsepower LS3 kit, we need to set up a few things. We're at the 750 horse, so I gotta set the injector flow to 55. It's a 376 cubic inch on LS3.